In this video, we're going to finish up lesson 5.1 by looking at example 3. Here in example 3, it says, find the dimensions of the rectangular dog park split into two pens of the same size, producing the greatest possible area enclosed, given the 300 feet of fencing. So let's give this a try. I always like to draw the picture first. So rectangular dog park. And it's got two pens of the same area. That's not really that critical, but you could draw it like this. Now, the way I've drawn it, I'm going to let these sides here be y and these sides here be x. You could have chosen them the other way, but we're going to do it this way. And we want all of this total fencing to be 300 feet, and we want to maximize the area. Greatest possible area. So let's see what we have here. We can make an equation of the fact that there's 300 feet of fencing and we're labeling them as X and Y. So here the 1X, 2X, 3X's plus the 2Y's would be 300 feet. Now, what we typically do here is we manipulate this equation to solve for one of the variables. So if I try to solve for Y here, then I would subtract my 3x from both sides, divide by 2, and we're going to get y equals 150 minus 3/2 x. That'll work. Now, what we want to do is find the greatest possible area. So what we call that is that we want to maximize the area. If we wanted the smallest area, we'd say we wanted to minimize the area. So we look at the area of this shape here. So we want the area of one of the pens plus the area of the other pens. And the area then would be represented by x times y, even though it's split into two parts. So x times y would be my area. But the reason we solved this for y is now we can substitute that in for y. So we'll just be looking at an equation that has one independent variable. So this is going to say a equals x times 150 minus 3/2 x. Multiplying this out, we'll get the area is 150 x minus 3/2 x squared. Now let's analyze this for a second. This would be a quadratic function because we have an x squared term here, and it's a negative a, so we know the quadratic function opens downward, and it's going to have a vertex here, which would be its maximum point. Now, since we're trying to maximize the area, we want to find that maximum point. So we're going to do the negative b over 2a trick. Our vertex would be that the x coordinate, we'll call hk, the coordinate of that vertex can be found by letting h equal a negative b over 2a. So let's start there. Now this function isn't written in descending order, so I'm going to write it as a negative 3/2 x squared plus 150x plus 0, there's no c. So there's my a, there's my b, and there's my c. So a negative b over 2a would be a negative 150 divided by 2 times a, which is a negative 3/2. Now, if we're smart about this, we can just cancel the 2's in the denominator, and we have a negative 150 divided then by a negative 3, which gives us 50. So it looks like that's our x coordinate. To find our y coordinate, we would substitute the 50 into my function. So we're going to get a negative 3/2 times 50 squared plus 150 times 50. And then plus 0 we don't need to do. So that 50 squared is 2,500 times 3 is a negative 7,500 over 2 plus 50 times 150 is 7,500. So is that right? Yeah, that's right. So what we wind up with here is a positive 7,500 over 2, or 3,750. So that is going to be in feet. Is it feet? Yeah. Feet squared. And this would be, of course, feet. Did we answer the question? I don't know. It says to find the dimensions of the rectangular dog park. Okay, so this would be the dimension of your X, and 3750 would be the overall area. Well, I guess we could divide 3750 by 50 to find Y, or use this function where we substitute 50 into the equation. Either way, we're going to get 75. So our X is 50 and our Y is 75. Again, the way we could find that is substituting it into this equation or substituting it into this equation with 3750 in for A, and X is 50 times Y. So if you divided that, you would get 75. So our dimensions are 50 feet by 75 feet. Hope that worked okay for you guys. Thanks for watching, and we'll see you in our next video.